Hi, my name is Kristen. Welcome to this journey through digital product design and 3D printing. Today, we are going to study the chapter, which is 3D modeling with Fusion 360 Ta SolidWorks. In this chapter, we'll explore how modern engineers create digital models using powerful CAD tools. We'll learn about sketching, applying dimensions and constraints, using features like extrude and revolve, building assemblies, and exporting models for 3D printing. These tools are essential for turning ideas into real, working parts. Let's begin. 2. Sketching tools. Basics. Sketching is the starting point for every 3D model. In Fusion 360, or SolidWorks, sketches are drawn on a flat 2D plane and later turned into 3D shapes. You can draw lines, circles, rectangles, and splines. Choosing the correct plane, like front, top, or right, is important for defining the orientation of your model. A well-planned sketch forms the backbone of a successful design. 3. Sketching tools. Advanced features. Both Fusion 360 and SolidWorks provide tools like trim, offset, mirror, and pattern. These help in editing and repeating sketch elements easily. You can also use constraints while sketching to control relationships between lines or shapes. Use mirror to create symmetric parts and offset to maintain uniform spacing. Clean, organized sketches reduce errors later in the design. 4. Constraints. Controlling geometry. Constraints help control how sketch elements behave. For example, you can make a line horizontal or 2 lines perpendicular. Some common constraints are equal, parallel, tangent, and coincident. They make the design more predictable and easier to modify. Fully constrained sketches are essential for professional modeling. 5. Dimensions. Defining size. Dimensions are added to define lengths, angles, and positions. In Fusion 360 and SolidWorks, dimension tools let you specify the size of lines or the distance between features. Smart dimensioning also makes your design responsive to future changes. Avoid over-defining sketches. Once it's fully constrained, stop adding extra dimensions. 6. Extrude. Making 3D shapes. Extrude is one of the most used tools in CAD modeling. It pulls a closed sketch into 3D, creating a solid. You can also use it to cut material from an existing object. Options include setting the depth, direction, and taper angle. Extrude is ideal for basic shapes, like boxes, walls, or mechanical parts. 7. Revolve and sweep. Creating curved forms. Revolve is used when you want to spin a 2D profile around an axis to create round parts like cylinders or wheels. Sweep moves a profile along a path, useful for pipes or handles. These features allow you to create complex, curved designs that extrusion alone can't handle. Use them when your part has rotational symmetry or needs custom profiles. 8. Assembly design. Overview. Assemblies let you bring multiple parts together to see how they interact. Each part is a separate body, and you can position them inside an assembly file. In SolidWorks, you create assemblies in a new document. In Fusion 360, you can build them in the same file. Assemblies help you understand fitment, alignment, and motion. 9. Assembly design. Best practices. Always organize components with clear names and use ground for fixed parts. You can use either top-down, designing inside the assembly, or bottom-up, importing separate files, methods. Use visualization tools to check for interference or gaps. Planning the assembly layout early helps avoid mistakes later. 10. Joint mechanisms. Understanding joints. Joints define how parts move in an assembly. In SolidWorks, you use mates. In Fusion 360, there are rigid, revolute, slider, and ball joints. These simulate realistic movement, like rotating wheels or sliding doors. Joints add life to your assembly and allow motion simulation for testing. 11. Joint mechanisms. Motion simulation. Motion simulation shows how your assembly behaves under movement. You can apply limits to joints, animate motion, and even study how parts move over time. These simulations help detect mechanical problems early. They are essential for designing linkages, gearboxes, or moving machinery. 12. Exploded views. Introduction. Exploded views spread out the parts of an assembly to show how they fit together. They're useful for understanding structure and for assembly instructions. Each part is moved outward along a set direction. This makes internal components visible and explains the product visually. 13. Exploded views. Practical use. Exploded views are often used in manuals, documentation, and manufacturing. You can also generate a bill of materials, BOM, from them. In Fusion 360, you use the animation workspace. In SolidWorks, the Exploded View tool does the job. These visuals are great for communicating design intent to others. 14. Parametric design. Concept. Parametric design uses variables to control dimensions and relationships. Instead of setting a fixed size, you define a parameter like width chastas to x thickness. When one value changes, related features update automatically. This makes your model flexible and reusable. 15. Parametric design. Efficiency. Using named parameters helps in modifying designs quickly. If you need a product in 3 different sizes, just update the parameters. The model updates instantly. This is useful in mass production or when working on design variations. Parametric modeling saves time and reduces human error. 16. Exporting STL files. Why STL? STL files are used to prepare models for 3D printing. They convert your model into a mesh of triangles. STL files are accepted by slicer software, like Cura or Prusa Slicer. It's important to ensure your design is solid and has no holes before exporting. Exporting correctly avoids print failures. 17. Exporting STL files. How to export. In Fusion 360, right-click the body and select Save as STL. In SolidWorks, go to Save As and choose STL as the format. Always check the unit settings, mesh resolution, and part orientation. A high-resolution mesh gives better print quality, but increases file size. Use 3D print previews before printing. 18. Recap. What we covered. We began with sketching, moved through dimensions, constraints, and features like extrude and revolve. Then we looked at assemblies, joints, and exploded views. We explored parametric design and ended with STL exports for 3D printing. These tools make up the core of digital product modeling. Knowing how to use them sets the foundation for engineering innovation. 19. Applications in the real world. These CAD tools are used in industries like automotive, aerospace, consumer electronics, and even healthcare. Engineers use Fusion 360 in startups and product design, while SolidWorks is used widely in mechanical and manufacturing firms. The skills you're learning now will help you in internships, projects, and industry jobs. Practice makes a designer perfect. 20. Conclusion. Thank you for being part of this session on 3D modeling. Keep exploring, keep practicing, and don't be afraid to create. In the next chapter, we'll look deeper into rapid prototyping and design testing. Until then, happy modeling.